we are going to be starting our new unit today, and our new unit is going to be on 2D and 3-dimensional objects. And we're going to start off just by reviewing things that we should know about area. So area is going to be for 2-dimensional objects. I'm guessing some things that you probably already know, things that you remember, are area formula of a triangle, which the area of a triangle is 1/2 base times height, or you may have been taught base times height divided by 2. Those are the same things. Divided by 2 is the same as multiplying by 1/2. Maybe you also remember the area of a rectangle, which is base times height, or you may have also been taught this as length times width. So those are the two that most of the time you guys will remember. Sometimes you'll remember the circle formula that you've learned already. You probably have learned all of these formulas, but maybe you have forgotten. So if I ask you to find the area of a 2-dimensional figure, and let's say you forgot, or you can't find your formula sheet, or you're not quite sure what to do, one thing that you can always do is you can always take these objects and break them down into basic pieces of things that you already know. So if I look at this first shape in number 1, this is a parallelogram. We know all about parallelograms. We learned about all their properties, but we never learned how to find the area. Maybe you forgot how to find the area of a parallelogram. But if I look here, I see that I can break this down into a triangle. And this triangle is 1/2 base times height. One of the most important things that you've got to remember is that the base and the height are the two sides that run perpendicular to each other. That's how I can decipher between which numbers you use and which ones that aren't relevant here. And I see that there's that right angle being formed, so I know that 3 and 6 are my base and my height. And it doesn't matter which one you write first, which one you say is your base, which one you say is your height, because they're going to be essentially the same in our formula. And then I can multiply this all together at one time. So 1/2 times 3, which is 1.5, times 6. Or you can say, okay, what's half of 6? Oh, that's 3. 3 times 3 is 9. You also have your calculators in front of you. Area is a 2-dimensional it's the area of a 2-dimensional object, so it is going to be centimeters squared. So this triangle right here is centimeters squared. If I look to the other side, I can also break this into a triangle as well. Now, I don't have any numbers here, but I do know from our parallelogram unit that opposite sides are congruent. So if this side is 11, 3 plus 8, then this side also has to be 11 centimeters. When I look at the object in the middle, we have a rectangle or a square. We don't know it just yet. But if this side right here is 8, then this has got to be 8, which is going to mean that this is going to be 3 just like over there. If I want to, I can go ahead and go in the middle. The area of our rectangle we know is base times height. And remember, the base and the height are going to run perpendicular. So that's going to be 8 times 6, which is going to be 48 centimeters squared. Oops, forgot the 8. 48 centimeters squared. And then we have this triangle over here. And again, if it's 6 over here, it's going to be 6 over here. This is actually going to be the exact same triangle, 1/2 base times height. Those are going to run perpendicular. So 1/2 of 3 times 6. We did that same thing right here, so we know this is also going to be 9 centimeters squared. What I did is I broke it down into the little pieces that I did know. So this one is 9, this is 48, and this is 9. So the area of my whole figure is I add those pieces together. So I can always take my figure, break it down into smaller pieces, and then add them together in the end. So my total area here is going to be 66 centimeters squared. We look at number 2, and hopefully right off the bat, you're like, I know what shape that is. This is going to be a trapezoid. We're actually going to come back to this question after we've learned our formulas. We did one breaking it down, and then we're going to do one example applying the formulas from today. So remember, If you did not print this off, which is totally fine, you should be writing all of this down on a separate sheet of paper. You don't have to print it every day. Here are all the area formulas that you're going to need for two-dimensional figures. So our first one is the triangle. We already talked about the triangle. Today we're really just going to focus on what are the formulas, what are the parts of the formulas, and where do I see that in my object. It's more understanding today. So if I look at this dashed line is saying that's not actually part of the triangle. The triangle itself is right here and right here. When I look at my formula, it's A equals 1/2 B times H. B is going to be base length, the length of my base. H is the height of the triangle. Because I'm in the triangle formula, this H is representing the height of that triangle. Now, when you look at a triangle, these pieces can come in different ways. If you have a right triangle, the height and the base are already part of the triangle and they are running perpendicular to each other. Because as we said up above, it's important that the height is always perpendicular to the base. Now, if I look at the next triangle, this one looks a little bit different because we don't have a right triangle where one of my angles is a right angle. The height is going to be where I go from the vertex of my triangle and I'm going to drop it perpendicular to the base. So the base is one side of my triangle and the height is going to be another number that I'm going to have to find. In an obtuse triangle, the height of your triangle is going to be shown outside of the triangle. The base here, the height, again, we see that in all of these, it's running perpendicular. Sometimes the height is part of the triangle, sometimes it's inside the triangle, and sometimes it's outside of the triangle. Here, for a parallelogram, so this is what we had above, your area formula for a parallelogram is B times H. So again, B is going to be your base length, and H is going to be the height of the parallelogram. Since I'm in the parallelogram formula, H still stands for height. Sometimes you see the height of the parallelogram outside, and sometimes you see the height indicated inside. The key, again, is that perpendicular relationship. I don't want you to forget all the properties of parallelograms because those come into play. The opposite sides are congruent. So it doesn't matter if I'm using this base or this base, they're going to be the same number. Then we get to our trapezoid. When we look at our trapezoid formula, it's A equals 1/2 H parentheses B1 plus B2. So our H is going to be the height of the trapezoid because we're in the trapezoid formula. Then we have B1 and B2. We see B1 is going to be base 1 and B2 is going to be base 2. Don't forget to read here, it doesn't matter which one is base 1 and which one is base 2. Now we don't have that paper demo, we're not in class. So the base 1 and the base 2 here, it doesn't matter which one you say is base 1 and which one you say is base 2. What we do know from our quadrilateral unit that base 1 and base 2 are the two sides that run parallel to each other. In a trapezoid, two sides are parallel, two sides are not. So when you're choosing the bases, make sure that you're choosing the two sides that run parallel to each other. Then we have our circle formula. Again, this is probably one that you already know. The area of a circle is pi times r squared. And we know that our r stands for our radius. And we finish our circle unit, so we know exactly what our radius is. It goes from the center of the circle to the outside. Here is a little demo. This YouTube link right here on explaining the formula for the area of a circle. I emailed out the Word document so you can click on that YouTube video and watch it if you would like to help understand that. The other one here is the circumference. The circumference is 2 times pi times r. And some people just instead like diameter times pi, but it doesn't matter. Again, they both represent the exact same thing. The formula for the kite and the rhombus is the same formula. So it doesn't matter if you're looking at a kite or if you're looking at a rhombus. It's the A equals 1/2 d1 times d2. So the area is 1/2 diagonal 1. So connecting one corner to the other times diagonal 2, connecting the other two. And you can see that it's indicating that relationship outside. So D1 and D2 are diagonal 1 and diagonal 2. In your rhombus, you can see that AC is one of your diagonals and BD is your other diagonal. So the diagonals connect the corners. Whether you're looking at a kite or a rhombus, what we need is those diagonal links. And then our last shape is our regular hexagon. There's a lot of different things about a hexagon, and there's different formulas. This one only works for regular hexagons. And the key here is that S is going to stand for your side length. Now, because it's a regular hexagon, all of these sides are actually going to be the same. Where this formula comes from is it talks about 6 equilateral triangles. And we're not going to really get into that right now, but just know that that's why this is 6 times this quantity, because if I had an equilateral triangle, s squared root 3 over 4 would be that area formula for any triangle. But again, for a regular hexagon, the only thing you need in your picture is one of your side lengths, and then you can plug it into your formula. So let's go ahead and go back to that problem that we skipped before. When you're looking at a shape, the first thing that you do, we already did, is you identify what shape do you have. Do I have a triangle, a parallelogram, a trapezoid, a circle, a kite, a rhombus, or a regular hexagon? Choose the object, because then that tells you which formula to go to. So because I have a trapezoid, the area is 1/2 height base 1 plus base 2. I look at what I'm given. I have that this is 10. I have that this is 26. These right here are my bases. It doesn't matter which one you say is base 1, which one you say is base 2. What I'm missing is the height. Now this is a little bit harder. We have to solve for the height. But what I do know is that the height is going to run perpendicular to the base. And if I follow down this other side right here, if this is 10, then this has to be 10 as well. Not only is this a trapezoid, if I look over here, the legs are the same. It's an isosceles trapezoid. So when I tell you that this whole length of this base right here is 26, and this part of it is 10, if I do 26 minus 10, I'm left with 16 for here and for here. Because it's isosceles, it's going to be split evenly. So this is 8, and this is 8. Which I know seems a little out of sorts here, but we're using this so that we can find the height. Because this is running perpendicular, I have a right triangle and I can do the Pythagorean theorem. And remember, the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So that's 8 squared plus height squared, which is that other leg, is equal to the hypotenuse. Remember, the hypotenuse is that side across from that right angle. And after I do that Pythagorean theorem, I find that my height is 15. So I go back to my formula. I have 1/2 that height that we found there at 15, base 1 plus base 2. Now notice how these are in parentheses. I need to add those two numbers together first to get 36. So it's 1/2 times 15 times 36. I multiply all of that together and I get 270. We didn't have units this time. Last time we had centimeters. So it's just units squared. Okay. Again, that is your intro understanding of all of your area formulas. Go ahead and look at your homework and see if you can identify the shape and then apply the formula for each of those shapes. All right, bye.